So moving on to HELM, this benchmark stands for Holistic Evaluation of Language Models. It was developed by Percy Liang and his team in 2022, last year. And there are several reasons why it actually stands out as a very comprehensive way of assessing language models. It was designed top-down to ensure broad coverage, and that also means like it recognizes that there are certain areas in which it is incomplete. It covers a large number of scenarios. A scenario is defined by a combination of a task, like question answering or summarization, sentiment analysis, and a certain data set like Wikipedia articles or movie reviews. There is a set of users where this data set is coming from. This might be web users, there might be specific genders represented there, specific ethnicities, ages, and so on. The data set is also coming from a certain period and comes in a given language. Actually, HELM recognizes like it is focused on English language, and it recognizes this is one of the gaps. It does not cover languages beyond English. And then these different scenarios, like there's in total, I think, more than 20 scenarios. They are evaluated against multiple metrics. And again, the insight here is a lot of benchmarks like over index on accuracy, but as a society, we care about many other values as well. So in the case of HELM, they definitely look at accuracy, but they also check the robustness, fairness, toxicity, efficiency of these language models. And in order to evaluate language models fairly, there is a certain level of standardization being applied. For example, when you use a language model in a particular scenario, you need to adapt it in a specific way. And the team puts also like a special effort into doing this consistently across language models. So what are some scenarios? And in this case, like we'll start with the different tasks. So a task might be question answering, and the scenario here is MMLU that we have already seen in the Hugging Face leaderboard, which is like a multiple choice question. The next one is information retrieval. And this example is the MS Marco dataset. In case of information retrieval, we get an input, which typically is a question, and then we have a set of reference documents and we need to rank them. And ideally, the document that contains an answer to the question is at the top of the rank. We have summarization task on the CNN Daily Mail dataset. We have sentiment analysis on IMDb movie reviews. We have toxicity detection, which is a binary classification. You get a given input and need to decide is it toxic or not. And we also have this miscellaneous text classification, where we have some input, some text, and a number of classes, and we need to classify it into one of the provided classes. And then a scenario is a combination of different tasks with a specific data set. And these scenarios are evaluated on several metrics. And again, the philosophy here is the metrics should reflect a range of societal considerations. They should be quantitative. They should not require assumptions on how a given language model works. It should not require us to understand a broader system or a broader context. And taking into account this criteria, HELM actually measures accuracy, measures uncertainty or calibration, robustness, fairness, bias, toxicity, and inference efficiency. So let's look into each of these metrics to understand it a little bit better. Accuracy, this is actually a family of metrics. So the most straightforward one is exact match accuracy in the case of text classification. But for question answering, the accuracy metric might be F1, which is for word overlap between a reference answer and the provided answer. In the case of information retrieval, we might evaluate it with mean reciprocal rank or NDCG. And these metrics are pretty established in these different domains. We will not get into the detail to understand them, but I recommend you checking out if you try to understand the information retrieval use cases or summarization. It might make sense to look into the details of these metrics. And here, as a side note, as an example, specifically for summarization, the metric that has been used since 2004 is called Rouge. And this metric is in a way similar to BLUE. It's a bit different because it's focused on the recall versus precision. It also measures the n-gram overlap or recall between the candidate summary and a set of references summaries. And again, historically, this has been very helpful metric to progress the summarization task and the models that work on summarization. But in the era of GPT-4, where language models are really good, this metric might no longer be so relevant. So the team at HELM, they actually performed some human evaluation of the summarization task to understand this a little bit better. They found out first, like Rouge scores tend to be much lower than human judgments. They surprisingly found that the reference summaries in the summarization datasets are low quality, and people evaluate model-generated summaries higher than the reference ones, which is a big issue with the benchmarks that we're using for summarization. And they also found human evaluations and automated evaluations were anti-correlated. So while Rouge favored the models that were fine-tuned on summarization, people that evaluated the summaries, they actually preferred the few-shot or the zero-shot language models. So there's definitely room for improvement in evaluating the summarization task. So moving on to the other metrics, calibration and uncertainty. The metric here is called ECE, or expected calibration error. The way you calculate this metric is you divide your predictions into histogram bins that are equal size based on the probabilities. And then in each of the bins, you calculate accuracy. You calculate the average probability. You measure the error within a bin as a difference of the accuracy and the probability, and then you average. You do a weighted average over the errors across all of the bins. So that measures how a language model is calibrated. And if you want to use predictions from a language model in real world, it's good to have a calibrated probability, because then based on that probability, on the probabilities, you can take different actions. So that's a helpful feature for a language model. Robustness, so there's a bunch of metrics that is calculated using different perturbations. So starting with robustness, we might add certain perturbations in the input to a language model. We might add typos, we can replace words with their synonyms, and we would, like, if a model is robust, we would expect its prediction to be invariant to these perturbations. In a similar way, we can measure fairness. So in this case, if we look at the gender dimension, we may change an input and substitute gender. Like in this case, we substitute he for she, and we would still expect the model to come up with the same prediction. And that is a way of looking at fairness. In the case of bias, we can look at different model generations and calculate how different like demographics, for example, might be, or how different genders might be represented. So we can count the number of male or female terms within certain number of generations and calculate the gender representation bias. We can calculate the co-occurrence, for example, of like how often is mathematician associated with male terms, how often is mathematician associated with female terms, and based on that, calculate gender association bias. Toxicity metric, this is rather straightforward, but it requires having a way of evaluating the toxicity of a given generation. Once we can classify a generation into toxic or non-toxic, we can calculate the percentage of toxic generations and come up with a toxicity measure. And finally, inference efficiency. This measures like the latency of language model, how quickly it can predict, and we need to normalize it by the number of tokens across both the prompt and the output. So I encourage everyone to check out and read the HELM paper. It's almost like a book. I think it's definitely more than 100 pages. It contains a lot of insights, not only about evaluation, but also in how the language models work. One specific insight I wanted to share is this correlation between accuracy and other metrics that were measured in HELM. And you can see a pretty good correlation between accuracy and robustness and accuracy and fairness. But on the other hand, there's little correlation with calibration error. Seems like the relationship between accuracy and bias or toxicity or inference time is rather, I mean, these are rather uncorrelated. So something to keep in mind as you make different trade-offs in terms of metrics that are relevant in your application. So to summarize HELM, there's, apologize for this dense slide, but again, this is like a super insightful paper. It highlights some of the limitations. It did not cover languages beyond English. It does not cover some of the emerging tasks which are for which language models are used, such as creative copywriting, email generation. It found some limitations in evaluating long form generation. It also highlights that different language models may be sensitive to the way the prompts are being formatted. So it may be hard to compare models in a standard way, while they might have been trained in different ways. Just to maybe focus on the last 2 points, they also mentioned that it costs a lot of money to run these evaluations. For that reason, they actually limited, I think, the number of examples per scenario to 1,000 examples and 3 generations per example, which impacts statistical significance. And they also avoided aggregating model performance to a single number or a set of numbers. And that's actually something that is being solved in a way by MosaicML Model Gauntlet. So that's something that has been released quite recently. It's part of MosaicML tool called LLM Foundry, and it aggregates scores across 34 different benchmarks. It organizes them into 6 broad categories, such as common sense reasoning, world knowledge, programming, reading comprehension, and so on. And the big benefit of using this tool is that it is very fast. So it benefits from a lot of performance optimization, which means you can evaluate your model more frequently, and that means you get more insights into how your model is doing. And I feel like this radar chart, like there is some critique of these charts. I find them actually quite useful for comparing like which tasks like the model might be good at, the different models might be good at. So summarizing benchmarks, I think the first quote comes from the HELM paper, and I found this like really insightful. So benchmarks orient AI, they encode values, they set priorities, they specify directions and help us improve our understanding of technology. I think there's a lot of value of benchmarks. If you remember ImageNet, which like allowed for this huge progress in computer vision, I think some of these benchmarks also allow us to progress on the language model front. On the other hand, there is the Stratton's law, which says like when a measure becomes a target, it ceases to be a good measure. And we see like some of the benchmarks that are that might be overfitting to the benchmarks. And if people focus too much on getting a good score in a benchmark, that may not necessarily transfer into a useful or a helpful language model.